All right, so now we're going to be taking some notes on similar figures, which is our last section of our proportions unit. We'll be taking our test soon. So first off, congruent figures. Congruent figures have the same shape and the same size. So we're going to draw a little example here. I'm going to try to draw two triangles that look as close to the same as I can. The symbol that we use to show that two things are congruent, it looks like an equal sign with a little squiggly over top. So I'll write that bigger over here. Again, it's an equal sign with a little squiggly. That symbol means that those two shapes are congruent. So when I have two triangles or two shapes that are congruent, usually we name them by putting letters with their angles. So I'm going to go ahead and write that this one is triangle ABC. So if I wanted to write that they're congruent, I draw a triangle because it's a triangle, and then I list out those angles, ABC. Now if I wanted to show that that triangle is congruent, I want to use that symbol. And then I'm going to give that other triangle its own letters. So the angle that is up here, I'm going to name D. Down here is going to be E, and here's F. Now, when I write out my statement, I have to make sure that I list them in the ones that go together. So if I'm talking about A first, there we go. So if I'm talking about A first, I'm looking for where A is on that triangle, and then I'm going to look for the angle that goes with it. Well, the angle up top that's in the same spot, that's going to be angle D. So I want to list D first. Now I'm going to look for angle B right here because it was second. So I'm looking for B, and I see that E is in the same spot. So I'm going to write angle E. And then the last angle, I just want to make sure they're in the same spot. Angle C, there it is here, F is in the same spot. So I can list that one last. So the order definitely matters when you name these triangles and when you say that they are congruent. So now let's talk about similarity. Well, similar figures also have the same shape, just like congruent figures, but here they have different sizes. So for example, I could have a very, very tiny triangle ABC, and then I could have a bigger version of that same triangle, same shape, but now it's much bigger. This is triangle DEF. So when I want to write out that congruency statement, again, I'm going to start out with triangle ABC. And the symbol that we use for similar is just the squiggly. So again, off to the side here, just that one squiggly alone means that they are similar. So there's my little statement. Now I got to make sure that I put them in the same order. So again, triangle, I looked for A first because that's what I listed first. I see that D is in the same spot. Now I'm going to look for B. I see that there's E, and then F. So we named them pretty much the same way. The only difference is the symbol that we use there. All right, so make sure that you have that because when I scroll down, you will not be able to see it. All right, step 3 on our notes. This is all about similar figures. So similar figures, the corresponding angles are congruent. Remember the symbol that we use there is the equal sign with the squiggly. But the length of the corresponding sides are proportionate. And this is why this all falls into this unit, because we have to look for the corresponding sides and make proportions to explain them. So now we're going to fill out this chart here. It says to draw examples that fit each category. So they give me a shape. So a similar example could be a much bigger triangle. Again, we want the same shape, but maybe it's 2 times as big. So this side here that's 2 might be 4. And then this other 2 would also have to be 4. And the 3 would turn into a 6. So all those side lengths are 2 times as big. They're proportionate. But if I made a triangle that was 2 times as big on those sides, but maybe only half as big on the bottom, that does not work. Those are not similar. So if you change one, they've all got to change the exact same way. Let's look at this square down here. A similar example could be a little tiny square that's 1 all the way around, because this one is 5 all the way around. But if I made this side 1, but made this side 5 still, that would not be similar. So again, these are non-similar examples on the right. Last one, I could make this rectangle similar by doubling the side lengths. So 4 times 2 is 8, 11 times 2 is 22. Those would be similar. Those sides are proportionate. But if I only change one side and the other one stays the same, that would not work. Make sure you have that chart copied down because I'm going to be moving on and you will not be able to see it. So what does all of this mean for test questions? Well, number 5 is exactly like questions that you could see on your test or on your SOL. So they've given us a picture with 2 triangles, and we can see that these are similar triangles. Write yourself a little note. These are similar. Remember, similar triangles have the same shape, so you can see that they look like similar shapes here. But the difference is that my first triangle is much smaller than my second triangle. So if I wanted to use a proportion to solve for this missing side, I'm going to go back to my WKU here. Actually, yeah. So the difference here, though, is that this is not a word problem. My W is kind of tough to figure out. So if I wanted to make sure that I know which ones go together, and that's the whole point of words, is that I'm going to look for the numbers. So here I'm going to start out with the number 2, and I'm looking for the number that goes with 2. Well, if I look on the other triangle, the side that looks like it goes together is that 5. So I'm going to put a circle around both of those. So the first word that goes with those matching sides, I'm going to go ahead and draw a circle there to show what it is. Now let's look at those other numbers. I've got this 3. I'm going to go ahead and draw a square around the 3, and I'm looking for the number that matches it. I'm looking for the number that goes with it. Well, in this case, it's not really a number, but it's that variable x. But now my words are really easy. I just use shapes to show which ones I'm talking about. So I'm going to use circle on top and a square on the bottom. So let's look at the triangle that I know all those numbers for. So this one right here. I know both of those numbers, so I'm going to put it in my K. Remember, the 2 needs to go on top, because I've said the circle needs to go on top in my W. So that means that the square goes on the bottom. In this case, it's the 3. Now let's look at the unknown triangle. That's where my X is. I still need the circle on the top. While I look at the circle on this triangle, it's a 5. And then underneath that square, that's where my X is. So now that I've set up my WKU, I can go ahead and cross multiply and solve for my equation. So I've got 2x equals 15. When I solve that and divide by 2, I get x equals 7.5. All right, make sure that you have that example copied down. We're going to move on in our notes. On the back of your note sheet, we're going to do a couple more examples together. Now, number 6 looks very similar to what we've seen in our WKU problems, but here they've actually drawn triangles in, so we've already seen a problem that looks like this. We're going to do the same thing, solve using a WKU, and I'm looking for those sides of the shape of the triangle that goes together. Well, let's start out with this 4 here. I'm going to draw a circle around the 4, and now I'm looking for what matches on the bigger triangle. So I'm looking, and I see that there's a 10 here. So my W, again, I'm using circle on top. Now let's look at those other numbers and find out what matches. I'm going to draw squares around these. So I have the number 5, and then this side, on this triangle, I have my question mark, which would be my X. So in this case, I'm kind of ran out of my WKU, but I've got my squares on the bottom. So when I look for what I know, that comes from this guy, because I know how tall he is, and I know how far his shadow goes. So I'm going to put the circle on top, which was a 4, and then I'm going to put the square number underneath, which was the 5. Now let's look at the U, that tree. That has something that I do not know on it. So I need to put the circle on top, that's the 10. And then the X, that question mark for how tall the tree is going to go underneath. So when I cross multiply, I've got 4x equals 50. When I divide by 4, I get x equals 12.5. Now I could have solved this the same way and looked for my numbers and then underline my labels just like we did for WKUs. But sometimes they give us the picture, so we can use these similar figures that they've shown us, the similar triangles, to help us figure out how those proportions relate. Let's look at number 7. This one says a building that is 70 feet high casts a shadow that is 150 feet long. So they haven't given us a picture here, but I can go ahead and draw it. It does not have to be a beautiful picture. I'm just going to go ahead and draw a building. So there's my building. My building is 70 feet high, so I'm going to go ahead and label that. And then it casts a shadow that's 150 feet long. A nearby flagpole casts a shadow of 60 feet. So I'm going to draw that flagpole. And the shadow is 50 feet. And then it says, how tall is the flagpole? So that's where my X is. I don't know how tall that flagpole is, so I'm going to go ahead and put an X there. Now this is very similar. It kind of makes a triangle, even though we don't really see that last side, but we can still use them like similar triangles here. So in my WKU, I'm going to try to draw circles around the numbers, circles and squares around the numbers that go together. Well, I see that I have a 70 here, so I'm going to put a circle around that because that's the first number I saw. And now I'm looking for what matches it on the other shape, the one with the flagpole. So I see that X is in the same spot. I'm going to put a circle around that. And now I'm going to try to figure out what matches the 150. And I'm going to put a box around the 150 and a box around the 50 because those are the ones that match. So my W, I'm going to go ahead and put circle and square. My K is from that building because I know both of those numbers. The circle goes on top, that's the 70. On the bottom I have my square, which is 150. And now I'm looking for the U, that flagpole. Well, the circle, I don't know, so I'm going to put an X, and then 50 is going to go underneath. So now let's go ahead and solve that proportion. I get 150x equals, and now I'm going to go ahead and multiply 70 times 50. I get 3,500. And now I'm going to go ahead and divide by 150. So when I draw my railroad tracks, divide by 150. I get x equals, and I got a repeating decimal, 23.3 repeating. And that's my answer here. Make sure that you have all this down because it's about to disappear. All right, last question on our note sheet. This is about scale drawings, and we've already seen some problems that have to do with scale drawings. So scale drawings are an enlarged, and remember that means a bigger picture, or reduced, remember that means smaller, drawing that is similar to an actual object or place. Okay, so let's look at this example using a scale drawing. So there's a lot of information up here, and you can go ahead and read through this, but I'm seeing something extremely important in my drawing here. They tell me that I have a scale. 1 centimeter is equal to 5 miles. And then I look over here, and it says on the map, Niagara Falls is 8 centimeters from East Aurora. So if I go back here, it says we want to determine about how far Maria has to travel to get from Niagara Falls to East Aurora. So let's go ahead and make our WKU. I'm going to look for the labels here. On my scale, I see both labels. I've got centimeters and I've got miles. So let's go ahead and put centimeters on top, miles on the bottom. What I know comes specifically from that scale. 1 centimeter, remember you got to line it up with wherever you put it in the W, is equal to 5 miles. And now I'm looking for that last number. Well, here I see my 8 centimeters. So because I put centimeters on top, I've got to put 8 on top. They're asking me how many miles it is actually going to take to get from Niagara Falls to East Aurora. So I don't know that yet. I'm going to use a variable to hold its spot. So now I'm going to cross multiply. I get 1x equals 40. And I don't even need to divide by 1. I know that x equals 40 miles. And we've seen these similar figure examples before. So make sure that you have all of your notes written down, answer this last question in the video, and then we're going to get ready to practice in our packet and on IXL.